Somebody should contact the presenter, please. We cannot hear anything.
Oh. Sorry about that. I was just asking earlier if you can hear me. Can you hear me now?
Yes, we can hear you now, but from the beginning, we cannot.
Sorry. In fact, I was even asking, thinking that I was on. Sorry. Do I need to go back? Maybe I just have to go back.
Yes, I think so.
Yeah, you
Yeah,
that's
let me just go back. Okay, sorry about that, please. So I thought I was going to be looking at Jamovi today. It's a free alternative to SPSS, and unlike SPSS, it's actually free. You don't need to pay for it. So SPSS have issue dealing with licensing, and a lot of us in let me just say developing countries, we tend to use crack softwares a lot, which is not actually a good practice ethically. So imagine you go to an international conference, you are talking with individuals, people, and how was your analysis conducted, which software did you use? No one can say is using a cracked SPSS. Everyone will just say, if you tell someone using SPSS, he just imagines that you have paid for it. So this is why I'm trying to introduce Jamovi, which is actually free. And funny enough, it even extends a lot of things that SPSS doesn't have in it. So I'm going to be talking about it today. So what I'm going to be talking about today, I'm going to be talking about working install, clean imported data, various analysis. At least some of the analysis we come across through in our day-to-day research, such as descriptives, t-tests, ANOVA, correlation, regression, and also chi-square. We'll also be looking at how we can bring out a standard reportable output that you can actually pass on to or pass your research message or your research reports through. Or you can even add it together with your manuscript, maybe when you're writing or your work. So what are the challenges we have with SPSS? SPSS is a good software, but it's paid. And the other option you have is to use the crack softwares, and which carries a lot of security risks. So a lot of us don't know that using crack software on our PC carries a lot of security risks. Because most of the times when they say your software is cracked, it means there's actually a virus that's put in the software to break it in, to break it. That means that virus allows you to use your system. If you notice, some crack software will tell you to off your antivirus once you install it, just because they don't want the antivirus to kill that particular virus that allows you to use that software. These are some of the risks that crack software actually carries, and also high cost. Imagine an undergraduate student trying to break the bank just to purchase SPSS. So this is also one of the issues. Then we also have licensing hassle. Institutions' licenses can expire. Some institutions might decide not to fund the software again. So all of these are actually difficult, maybe for someone, a researcher that is just coming up, or maybe a student in the university that just trying to conduct his or her thesis research. So we have some comparisons here and some of the advantages. So in terms of costs, told you that Jamovi is free. In terms of interface, Jamovi have a much more simpler and cleaner interface. I believe by the end of today, you even like it much more than SPSS I've been using before. It's easier to find options and easier to do analysis. We also have extensibility. We have what we call Jamovi library. So in SPSS, if you want to do structural acquisition model, you need to download Amos. Amos doesn't come with SPSS. So unlike when you want to do it in Jamovi, you just add a library and you work with it. If you have worked with R before, you find it similar to how Jamovi also operates. You need an analysis that is not in Jamovi, you just look for the library on the Jamovi community modus. In terms of reproducibility also, it's actually built on R Jamovi, so which means you can even get R code from it. And you just need to point and click. If you are not comfortable with programming, you just point and click, just like you do in SPSS, and you get your results. So you have two options, either use desktop app or the Jamovi cloud. Any of these two options, you can go with it and use Jamovi. So, okay. Hope I'm being heard. Can I continue? Okay.
Yes, please continue. We can hear you.
Okay. So now this is if you want to install Jamovi, you go to the Jamovi site. This is the site I was showing earlier on. You have two options. You can either use it in the cloud. What you see here is also the same thing you see when you download the desktop, only that this one is on the cloud. And I think it also have some paid alternatives with days to sponsor the software. But this one is actually completely free. So you can also use part of the cloud for free, but this is what is completely free. So you download this straight up to your PC, and it's just a single installation that you do and you get the software. So once you get the software, you should be having something like this. This is what you should be having. This is how the Jamovi software actually looks like. You're having an interface like this. It's very simple, it's not clumsy. So, but very easy to navigate and get some of the informations you need. Okay, so let's go take a quick tour on the interface. And so this is our interface, the Jamovi interface. So on this place you have here.
Sorry, Mr. Redwan, please, can you expand your screen? Maybe just make it bigger.
Yeah, I think it's expanded like this. I don't know, maybe it's from... Is everybody having the same issue?
I'm seeing the entirety of your screen. I think it is fine. Maybe it continues, and are you able to see the length and the breadth of the screen? I'm seeing that.
Okay, so maybe you should check his system, his phone settings. Maybe you can fix that.
Right.
This is not a common issue. Yes. Okay, so this is the screen. This is the Jamovi interface. This right-hand side is where your output is. This is where your data is. So that SPSS output viewer that you have is what they put for you on this screen in this place. So it doesn't, the SPSS output viewer actually opens and you can close it and open it. So this is already there for you. Then you have this spreadsheet here, just like in Excel and just like in SPSS. So I think, so here now you can see it's just like a new window that I opened. So you can see I have some columns here, A, B, and C. If you can notice in SPSS, there is this logo that you have in SPSS. It actually means category. So you can also see it's also the same logo that is being used in this place. So your tabs, you have 5 tabs. You have variables, you have data, you have analysis, you have plots, you have edit. So under variables is where you like edit your variables. In the SPSS, we have what you call a variable viewer. A variable viewer in SPSS is where you like edit the kind of your variables, you put categories and things like that. Then we have also the data. The data is now where you can compute new variables and transform. Then we also have analysis. This is where you can do all your analysis. So they already grouped the analysis together. If you need more, you go to this plus sign. This is called where you enter Jamovi library. So you have to be online. You can see all the external analysis that are on Jamovi, depending on what you want to do. Any analysis you want to do, you can just search in this place. These are currently available analysis in Jamovi. So any analysis you want to do, you can see them in this place. Power analysis for linear models. All of these are external, designed by other people outside, part of the community. They designed this. So if you need it, you just click on install and you get it. So then under each of these analysis, you can also see the kind of tests we have, the kind of various tests that we have. So most of these are some of the most currently or frequently used tests that you have in here. So when you need something much more advanced, you can go to this place to get it. So if maybe possibly you not see it, then that's where maybe you need to use an advanced software such as R for your analysis. But at least for most common analysis that people do, so everything should already be in Jamovi. Most of the common analysis. For advanced analysis, because even the SPSS doesn't do all analysis. So sometimes for advanced analysis, someone needs to go to a software like R or Stata to actually go and conduct the analysis in that place. So this is how the window actually looks like. So on this particular hamburger icon I'm looking at, we have this, you can see it's 6 options here. For you to create a new file or a new data, you click on this. When you want to open your data, you click on this. So we have 2 options. This is from my PC, as you are seeing it here, and this is data library. So this one comes with default. So I'm going to be using this for practice. These are some of these data sets. I'll be using them for practice today. Why this one is from your PC folder. That's where you see all of this. Then we have also special importation. You want to export a special file. Then we have save, your save as. We also have export. So export, if you want to export the result of analysis, you can see PDF here. We're going to be going through all of this today. So this is how the interface looks like. So I'm just going to show an example with a file. Let me just see if I have a CSV file. So let me try and import a CSV file. Open. I think I should have some files here. I think. Okay, this one should work. So this is a file I just imported now. So first of all, just straightforward, you click on open this PC, you click on browse to go to your file directory and you choose the file you want to import. So this is just a file I have that I just imported. You can see these different logos here, these different signs here. You can see them. This one looking like a ruler is continuous. When you click on it now, and you go to data, or you go to variables, sorry. Okay, so we go to setup. You have this. This particular window is what you have on SPSS variable view. They just summarize it in this place. When you click on setup.
Please, is anybody hearing anything? I'm not hearing anything.
Hello?
Hello, we can hear you.
Hello?
Okay, I think she needs to check her device. Or maybe it's the network. Can I proceed?
Yes, sir.
Okay. So this is the setup. This setup is the same thing you have in SPSS variable. They just summarize it in this place. You can go through various variables through this arrow. You can see these arrows. You can see these levels. So they just like condensed it into this particular small window. So instead of having like a variable view, you just have like a setup button whereby you can set up each variable. Now you can see measure type here. This thing that looks like a ruler. You have 4. We know that nominal and ordinal are categorical. They also have continuous. We have ID. So ID is for identification numbers or identification variables in your data set. So this crude oil production that you're looking at now, or crude oil price, is actually a continuous variable. So that's why I say we're giving it this continuous in this place. They also have the data type. So this is actually a decimal. So that's why you can see the data type here is decimal. Then if you want to specify a missing value, you can just specify a missing value in this place, which you don't have. So if you look at this place now, let me see if, okay, I think we don't have a categorical here. Let me take this as categorical, this year. Let's take this as a categorical. So we can see we have 2006 to 2026. Okay, so we're going to be taking this as our categorical. Now, this is where it is already set automatically by Jamovi to nominal. So I think, I don't know. Someone's mic is on, please. Okay, so this is where we actually set it to nominal or ordinal or continuous, depending on what you have. So automatically, Jamovi will look at your data set and give you the proper one. So you can see the levels here. You can even edit this level. If I don't want, or you can create levels. Let's say you want to add now, you just click on this button to add levels. So I can say 2027 and say OK. So you can see I've already created another extra level in this place. So this is what this particular button is used for. So you can move through various variables like this. So this is how this particular variable view for Jamovi actually works when you import your data set. So we just imported a CSV data set. You can import an XLX, that is Excel file. You can import an Excel file. You can import an SAV file, that is an SPSS file. You can also import that. So all of this, you just have to go to your open and you import. Is it clear? Can I proceed?
Yes.
Yes, please.
Okay. So now we're going to go to descriptive statistics and plots. So descriptive statistics and plots. So let's just use this data. So this is under this particular place, exploration. This is where you have descriptive statistics and plots. So if I want to get some descriptives about this data that I have, I'm just going to click on exploration, then click on descriptives. So once I do that, you can see I have all my variables in this place. I'm very sure I'm already familiar with the way this interface looks like, similar to also what we have in SPSS. You can see you have your descriptives here, then you have this field is in this place. So if I want to split by, I just want to carry my variables here. For example, now I'm interested in crude oil price variable. So you can see automatically I get the result in this place. If I want to add domestic production, you can see it. I have the mean, missing, mean, median, standard deviation, minimum, and maximum. Let's try for categorical. What do we have? So you can see it's treating our categorical because we're actually calculating descriptives. So for categorical, we can decide to put it to here. Let's split by this categorical now. Let's see. These are categorical here. So you see now we have split by our categorical. So for each year, it's telling us what the number. It's taking it by each year because you just split by categorical now. Or let me just take a better example. Let me see. I think. Let me see. Okay, we can use this. Let's use this. So we have one continuous length. This, the name of the data is tooth growth data. Is a sample data for ANOVA. So we have length, the length of the tooth. We have the supplements that particular individual took. We have the dosage. So go to the exploration. We'll go to descriptives. So if I take length to variables, I get the descriptives on the length because length is a continuous data. When I take supplements to split by, so you can see for every supplement, I'm going to get descriptive about that particular supplement. So the average length for those that took OG supplement is 20.7. For those that took VC supplement is what, 17.0. So these are you can split your descriptives. It's not like say you have a category. So if you already got your general descriptive, you want to split the descriptive based on various categories, use this particular split by field. If you want frequency tables, you can check on it. You get what? Frequency tables. So we have settings here for statistics. So various settings in this place. So if I want to include my mode, I click on here. You can see mode has been added. If I want to include some has also been added. Even skewness has also been added. So these are various statistical measures that we have. Kurtosis has also been added. Then we have what we call test of normality. For those who want to test for normality of their data before conducting parametric tests, such as regression analysis or t-tests. So we have this Shapiro-Wilk test. So you can see Shapiro-Wilk test is testing for under, don't forget that we have already split by this. That's why it's testing for each of these particular supplements. If I'm to move this now, you can see everything becomes normal. So this becomes the Shapiro-Wilk test for the whole of that particular length variable. So we also have outliers, most extreme. We also have mean dispersion. So these are various settings that you have based on what you want in your table. It's left to you. What do you want to be in your table? What are you including in your analysis? What are you including in your reports? So this is what this particular statistics tab actually does. So you can see you have here, you can change how the table is presented. Do you want variables across rows or you want variables across columns? So you can see it changes dynamically depending on what you want. So this is left to you. So we have some plots here. If you want an histogram, you get an histogram. See it here. If you want a box plot, you just check on it. This plot is also under, don't forget that we're still under these descriptives. We're under descriptives. So if you want a box plot, you have your box plot here. If you want your density, so density is more or less like a line on the histogram. So it gives you the density histogram instead of just a normal histogram. If you also want a bar plot, though bar plot is for categorical, we can't have a bar plot here, but if you are treating a categorical data, you can put bar plots and you get a bar plot. So we also have other types like this QQ plots. It's also used for testing normality. So you can see this QQ plot is for testing normality. These are things that one can want to include in analysis for proof of why you choose a particular statistical methodology. So we also have other things like the mean, for showing the mean on your box plots. If you also want a violin plot, we also have all of this. So these are all of the plots which we have under these particular descriptive options. So these are the settings that you have. Is this part clear before I proceed?
Yes, you can proceed.
Okay. So then we also have scatter plots under exploration also. So a scatter plot, let me change the data. So I'm going to be using this continuous data here for the scatter plot. So we have this scatter plot option. If you notice something here, it's showing what? Scatter. This scatter that you're looking at here, let me go to the modules and show you. Can you see it? It's part of installed library. So when you install a library, it's going to be showing here. By the time you install more libraries, it's going to be seeing it here. You're going to be seeing it here. You're going to be seeing it here. They'll be showing as options on your screen. So you can see this place now has already been grouped under this place, scatter plots. We also have Pareto plots. So this scatter plots also, this is the option. So we have all our variables in this data now are continuous. If you look at it, all the variables are continuous. All of them are continuous. So a scatter plot is just a mere way of measuring the relationship between two continuous variables. So I'm just going to say neuroticism should be on my x-axis, extraversion should be on my y-axis. So you can see this is the scatter plot that we have. Then you have various options you can use for a scatter plot here. How do you want your point size to be? You want your point size to be big, 9. You can see you have a big point size, or you want it to be very small. If you want it to be 1, you can see you have a small scatter plot. You also have regression line. You can show a regression line on this your scatter plot. So these are a lot of things that based on the kind of work you are working, you might want to do. So if when you choose an analysis, always try to look at these tabs to see if you have something that will help you to produce a very good result. Here you can even change you can give a caption. I can say neuro. Okay, sorry, this should be the title. I can give a title here. Neuroticism against extraversion. So you can see I already have my title. So once you even have this, you just copy it and you paste it in the work or inside your report. You can do that and also have a subtitle, plot caption. You can also do that, x-axis title, y-axis title. This also applies to other plots, not just the scatter plots. You might be seeing some of these options under other plots too also. They also have the axis. These are settings for the axis that you have. How do you want your axis to be? How do you want the scaling to be? Do you want it to be 2-unit scaling, or you want it to be 0.5 scaling, or you want it to be a 3-unit or 5-unit scaling? So all of this is what you can actually set up in this place. They also have your legend. So this is cases whereby you have something like a colored chart, for example, and you want to give your legend. You want to set your legend. So you can actually set your legend in this place. In this place, you don't have a legend. So in situations like a colored bar plot, you can actually set up your legend to be able to distinguish which particular category is this, which particular variable is actually what this. So this is it for the exploration. Also have the Pareto plot also, but mostly this also how the Pareto plot also works. It's just similar. Pareto plot is a count and the x-axis. So, but most of the common plots are actually the scatter plot, the bar plot, the histogram, and also some of the box plots. But if you also need the Pareto plot, you can actually go to this particular option and set it up. Okay, I think I might have opened. Okay. So we are going to go for a t-test, show how the t-test works. I think, okay, the t-test should do here. So what's actually the t-test? When do we usually use the t-test? So the t-tests are various types. We have the paired sample t-test, we have the one sample t-test, we have also the unpaired sample t-test. So we use the one sample t-test whereby we just want to test if a sample mean is equivalent or equal to the population mean, population parameter. We use the two sample whereby we have paired observations. A typical example is giving a patient a dosage, and next 3 weeks you give them another dosage and you record their BP. So the first dosage you recorded their blood pressure. Then the second dosage, which was after like maybe 3 weeks, you recorded a blood pressure. You can see these are paired observations, the same individuals, but different data at different points in time. So this is actually where you use a paired t-test. Then we have the unpaired. So unpaired is whereby in the unpaired, you don't even need to have equal samples between the various groups. So in unpaired is whereby two samples might be different. I want to compare whether they're having the same parameter, they're having equal parameter. Maybe, for example, population mean, they're having the same population mean. So if you want to do that, we have a section of t-test. You can see the 3 types of t-test here. So for one sample t-test now, let me do a one sample t-test on length. I'm going to be it on length. So I'll go say one sample t-test. So I'm going to choose the length, and so this is it. This is the p-value that we have for it, for the one sample test. You can see that it is not significant, which means that what? The average is not equals to 0. That's what it means. Sorry, we reject the null hypothesis in this place. So we're going to reject the null hypothesis, which means that what? So we're going to be using an alternative hypothesis that the average is what? Not equals to 0. So then you have other options here that you can set. We have things like bias factor for those that are doing Bayesian t-test, because also have what we call Bayesian t-test. That's another angle on its own. So that's what with Jamovi. Jamovi conducts Bayesian analysis. Some people, we have 2 types of statistical analysis. We have frequencies analysis, which is the normal analysis we are used to. The normal analysis that we're all used to is the frequencies approach. Then we have Bayesian approach. So any analysis that you see that we have in statistics that we are already used to, we have the Bayesian counterpart. So for those that are using Bayesian, you can actually set this. We have what we call prior, but it's actually beyond the scope of this class. So you can actually set this. Then we also have things like mean difference. Well, you want to get the mean difference. We have effect size. You have your descriptives. If you want a descriptives, you have descriptive plots. You want descriptive plots. You also want to check for normality, because one of the assumptions of t-test, you can check for it in this checkbox here. Normality checks using the Shapiro week. So you can see it's telling you that a low p-value suggests a violation of the assumption of normality. So which means that what? This, our data is normally distributed. Because if the p-value is less than 0.05, which is our standard level of significance, it means that what? That particular variable doesn't follow the normal distribution. So all of these are things you can check for using some of this particular checkbox. You can check for all of this. So you can see it closely follows a straight line. You might see some plots who are going to be curved, so curved that, in fact, you can't even trace a straight line on it. But at least you can still see that this curve follows a straight line a little bit. So these are some of the things that you can actually check under one sample t-test. Sometimes you want to test your hypothesis value. Like now, we're testing to 0. What if your population was actually, the average truth length from your population was, let's say, 13? You can see it has changed. So the value has already changed. The degree of freedom have changed. So this is where you can set your values. So this place is a what? 2 sample t-test. This is a 2 tail tests. Why these ones are one tail test? So one tail test is actually what? Unidirectional, just one direction, greater than or less than. Why 2 tail tests are usually what? Is usually not equal to, because we don't know which direction we're actually comparing with. So if you also want to, if you have missing values, you can decide to set any of these options. Exclude cases analysis by analysis, or exclude cases listwise. So when we say exclude cases listwise, it means more or less like what? Exclude the missing values that we have in our data. So that is for the one sample t-test. They also have the paired sample. I think I will have to go for the independent. I don't think I have a data for the paired, because most of the times in the paired, the number of the categories need to be equal. So I'm going to go for the independent. All what I've treated in the one sample is also what we have in independent. The only thing that's just changing now is that in independent, they're providing 2 continuous variables, while you give the grouping variable. So you want to compare the weights between the male and female male and female patients in a hospital. So your grouping variable is going to be the gender, because that's where you know that what this particular patient is a male or this particular patient is a female. Then you now have your what? Dependent variable is going to be what? Which is now going to be what? Length. So now I'm going to say I'm going to now group by supplements, which is what we have now. So you can see this one that we have here. The up was for the one sample. This one now is for the what independent sample t-test, which shows that what there is what no significant difference between the various supplements of that each patient took. Then you now have all these settings that I already explained earlier on. So we have what we call Mann-Whitney U. Mann-Whitney U is a non-parametric t-test. So non-parametric in the sense that once your data violates some of these assumptions, at times we might not be strict. If your data can go with one assumption, you can still proceed with your t-test. So mistakes some people actually do is that they just run analysis without checking for assumptions. We have what we call assumptions, which you have to check for. We have what we call test of homogeneity, which is equal variance. We have normality test. We also have QQ plots. These two tests for almost the same thing. So Mann-Whitney unit test is when you violate all of these assumptions. All of these assumptions, the data is not obeying it. Then you go for the Mann-Whitney U test. So it's called the non-parametric independent sample t-test, the Mann-Whitney U test. So usually used, so most parametric analysis usually have that non-parametric counterparts. So we have like the Mann-Whitney U test, which is for the independent sample test. We'll see for other ones too later on, maybe like for the ANOVA. So this is how it actually works. So anything your settings here depends on what you actually want in your analysis. What are you looking at? What do you want to put in your results? So this is what affects the kind of settings that you actually give in this place. So I don't know, is it clear? Can I proceed?
Yes, it's clear.
Okay. Okay, I think. Okay, so let's go for the one we are over. Okay, so now next thing. Okay, I already said for the peer sample t-test, I don't think I have a data that we can use because peer sample t-test needs the two samples to be equal, but you can just still follow the same approach. So what you also want to mention for the independent sample t-test, you can see here I told that this is a two-tail. We have one tail. So sometimes your hypothesis will be like, let's use for example this particular example, the length of tooth for those that took this supplement is the average length is greater than those that took these other supplements. So this is where you can use this. If it is the other way around, the length of two those that is supplement one is less than those that is supplement two. This is where you can now tick this. So this is just the kind of tail that you have. This is for the two tail, while this remaining two is for one tail. So we have ANOVA. So let's show this thing is this string. Okay. So we have ANOVA. ANOVA is a special case whereby we treat, whereby we have, okay, for the t-test now, if you look at it, we're comparing sample means between two populations, right, or two samples. So for the ANOVA is whereby you will now have more than two. So for example, now I'm comparing the average weight of patients in the hospital between male and female. Is the average weight equal or is not equal? So what if I'm doing for that of ethnicity? So we have Igbo, Yoruba, and Hausa. I want to compare the average weight of patients between these particular three ethnicity. Is it equal or is not equal? So this is where you now use the ANOVA because you're having more than two samples now. You're having 3. So you have 3, 4, 5, 6, you use the ANOVA. So I'm going to be restricting our class today to just this one way ANOVA. Subsequently, we might do other webinars on other advanced kind of ANOVA that I can see. We have Mancova, we have ANCOVA. We also have repeated measures ANOVA. We also have all this split block design. We also have randomized completely block design. So these are various kinds of ANOVA, but this is the simplest kind of ANOVA, the one-way ANOVA. You can see here we have what we call one-way ANOVA Kruskal-Wallis. So this is also the non-parametric alternative for ANOVA. ANOVA also has its assumptions. So most parametric approaches, most parametric approach, they have one common assumption. Most of them want their data to be normally distributed. What do we mean by data should be normally distributed is that when we plot this data on this graph, we want it to at least, it should like follow this line, close to a straight line. Even if it is not a perfect straight line, it should be close to a straight line. One will also draw the histogram, the density histogram, which I drew earlier on. It should look like a bell shape. We want it to have that kind of shape. Even if it is not a bell shape, something close to that. then we can now accept that that particular data is normally distributed. We can now proceed to what? Use that particular parametric approach. So, but in cases whereby the data violates that approach, then we now go for one-way Kruskal-Wallis ANOVA. So let's take the one-way ANOVA first. So the one-way ANOVA, let me see if I have, I think also this same data should work. Yeah, I think it's also work. We can use it. So the dosage has 3 levels. These are the groupings we have in the dosage. 3. There are actually 3. Then let's make it text. So we're going to go for the one-way ANOVA. So our dependent variable for the one-way ANOVA, just use the same concept of the t-test. It's just that now we're having more than 2. So our grouping variable is going to be dosage, while our continuous or dependent variable is going to be what? Length. So you can see the what? You can see the result of the one-way ANOVA. We have a p-value of less than 0.0, which means that what? There is significant difference between various dosage. We have significant difference between various dosage. So if you want your descriptive tables, your descriptive plots, you can decide to just choose all of this. You can see you have descriptive plots. You can see even from the plots, you know there's a lot of difference between various groups. So now, if you also want to check for assumptions, just like I told you earlier on, to know whether you want to go for a Kruskal-Wallis or you still want to stay with the parametric one-way ANOVA, you can check. You can see it's also close to our straight line. From the Shapiro week, what do we have? Okay, I think it doesn't. Okay, we don't have an option for that in this place, but at least you can use this place to just judge that what you can proceed with this particular one-way ANOVA. Then we have what we call post hoc test. So what do you mean by post hoc test? Your test already told you, unlike on a t-test, once there's no difference, you know that what you are dealing with only 2 groups, male and female, for example, or supplement type, supplement 1, supplement 2. But for an ANOVA, you are dealing with more than 2. So once your test tells you that there's no significant difference, it means that in that 3 groups, one of them is different. It's possible that all of them might be different, or out of 3 or 4 groups, one of them is different from the remaining. So you need to find out or fish out that particular group that is actually different. So that's where we need to conduct a post hoc test. Post hoc test is like trying to tell us that which of this particular dosage that we have here now is different from the other ones that we have. So we have various, these are just some of the few tests, but post hoc tests are plenty in statistics. We have Games Howell, and we also have Turkey. So you can see it now in this place. You can see we have a table, columns, and we have row. So these ones that are with the same variable is going to be having a dash. So dosage 500 and 1000, that's significantly different from the p-value. Dosage 500 and 2000, that's significantly different. Dosage 1000 and 2000, that's significantly what? Different. So which shows you that all the dosage are completely significantly different. You can have some cases whereby dosage 5000 and 2000 might be having 0.9 something. You know that one now, it means they are not significantly different because the p-value is greater than 0.05. So which means 5000 and 2000 are not different. But 5000 and 1000 are already different. So the fact that 500 and 1000 are different means the p-value in the ANOVA analysis is going to be what? Different. So that's the function or the use of post hoc test to let you know where that particular significant difference lies. You can decide to use the Turkey approach. So this is the Turkey approach. They're both the same. They're just different techniques of conducting post hoc tests. So we also have some other options in this place which you can add. You can also see this option, flag significance comparison. So once you see this particular 3 dots, it means there's a significant difference between these and that particular variable that is being compared with. So this is how you can conduct post hoc tests while conducting another analysis in Jamovi. Is it clear?
Yes.
Okay. So we are going to be going for correlation and regression. Correlation and regression. So we have, let me see, is okay. I'm just opening multiples. So this is the regression tab. So you can see we have two types of regression. We have the the linear regression. We also have the logistic regression. So logistic regression is usually used when you have binary outcomes, or you have binary outcomes, or you have n outcomes. We have two types of. Under the logistic regression, we also have various classifications. We have the binomial, which is for binary outcomes, yes or no. You want to predict whether a patient will die or not, or whether a patient will have diabetes or not, or whether a patient is going to survive or not. So these are various kinds of binomial cases. Why a multinomial case where you have n outcomes is whether someone is married. You are trying to predict whether someone is married, single, or divorced. You can see you're having more than 3 outcomes. So this is why we have n outcomes. So, but we're going to just take in the linear regression and the correlation matrix. So correlation is also where you compare two variables. You want to find out the relationship between two variables. How are they related to each other? That's where you use correlation. So all of our variables now here that we have, they are both continuous. So we can try to compare correlation between neuroticism and extraversion. So the interesting thing now with this place is that when you are computing correlation on a software, you can actually compute multiple correlations. That's why we have what we call a correlation matrix. So you have 5 variables that are continuous. You can decide to just compute correlation of these 5 to see what relationship they have with each other. So if I decide to select these 5, you can see the correlation matrix that I'm having. So we have 3 types of correlation. We have Pearson, we have Spearman, we have Kendall. This Spearman is more or less like a non-parametric correlation analysis. It's non-parametric. So then we have Kendall Tau. This Kendall Tau. So you can see, you can decide, it depends on what you want to use. You want to use the Pearson coefficient, or you want to use the Spearman coefficient, or the Kendall. All of them have the same interpretation. They must fall between the range of -1 and 1. You can't have a correlation above 1. You can't have a correlation between below -1. So they have to fall between these particular two values. So you can have 0 point something or -0 point something. At least it should fall between the range -1 to 1. Now, neuroticism and neuroticism, you cannot have a correlation. So any place you see a hyphen or a dash, it means that the same, both the column and the row are the same variable. So if you look at extraversion and neuroticism, they are having a Pearson correlation of -0.35. This is the value. Pearson R, this is -0.010 for openness and neuroticism. Agreeableness and neuroticism -0.134. Conscientiousness and neuroticism, you're having -0.366. So these are the various correlation values that you have. So a correlation matrix is very helpful. Instead of just conducting it one by one, you just plot something that you have once. If you just want between two variables, you can just decide to remove 3 here. You can see we're having just only 2 variables here in this place. So all of this depends on just what you want or we're actually trying to report. So we have what we call significant correlations. So significant correlations are correlations that are actually significant, that are actually meaningful. So you can see -0.35 is significant. This one is not significant because it's close to 0. So anytime you have correlation around 0, 0.05, 0.03, so all of these are not significant correlation, or -0.0 something. Because correlation of 0 means no correlation there. So it is neither positive or negative. So correlation between 0 to 1 is positive, and as it goes from 0 to 1, the strength increases. Why what 0 to -1 is negative. So as it goes from 0 to -1, the strength also increases. So anything around 0.0, 0.00, so all of these are what's not significant. So you can see that's why we're not having this triple asterisk in this place. So we can also have other settings here, your N, your confidence interval. We also have what we call a correlation matrix plot. So you can see it. This is called a correlation matrix plot. So you can see, you can have a correlation, just like what you have in the table, but represented in a plot form. You can see it here. Just like what you have in your table, but represented in a plot format. You can see with even the density for the various variables. So you can have something like this by using some of these options. They also have your hypothesis. Are you testing whether it's correlated positively or correlated negatively? So all of these are just extra settings that you have under correlation. So is it clear? Can I proceed to regression?
Yeah, you can.
Okay. Then we have linear regression. So I say I'm going to take linear regression. We'll leave the logistics for another time. For linear regression, so it's just basically you have your dependent and independent variable. So the covariates are what it refers to as the independent variables. While your dependent variable is actually what you are measuring. What is your study variable? That's your dependent variable. So let's take neuroticism as our dependent variable. And we take extraversion, and we can just take some of these as covariates. So you can see we have our estimates, we have our standard error, we also have our p-value. So because this let us know what and which of these covariates are actually significant in predicting neuroticism. So factors here is whereby you have categoricals. That's where you put factors. Where you have categorical variable, you have something like gender. This is where it belongs to. You put gender in this place. So this is actually an advanced option. There's what we call there's some kind of regression that we have that allows you to, especially we have plenty of variables. We have some of this regression we call stepwise regression. We have backwise regression, stepwise regression. So these are regressions: forward regression, backward regression. These are some kind of advanced kind of regressions. So this is where you actually do some of those. So some people's work might warrant them to actually do some of this kind of regression, whereby they start with a particular variable and increase the variables, increase the number of covariates they have in the analysis. So this can actually be done in this particular path model builder. So we have reference level. We don't have a categorical. That's why you see we can't do anything here. So reference level is just whereby you have categorical. Because when you have a regression with categorical, this is where you now refer to. You have a reference level. You explain your dependent variable based on the reference level. We also have assumption checks because you need to check for assumptions for a linear regression. One of the important assumptions is normality of your data. Your dependents have to be normally distributed. I already explained that now using the Shapiro weak test. You can see it has to be normally distributed. We also have QQ plot of residuals. You can see it's, in fact, almost close to a straight line. In fact, from this graph, we can conclude that this particular data is normally distributed. We also have residual plots. So these residual plots are actually, when we say residuals, they're actually fitted. When you conduct a regression analysis, it's like you're estimating a value. So we're estimating neuroticism based on these four values. So we will now compare our estimated value with the actual neuroticism value. So that difference is what we now call residuals. So this is the plot of residuals and fitted. You can see we already have it. So then we have collinearity statistics because we have what we call multicollinearity. When you have two variables in the data and you want to conduct a regression analysis and you have two covariates or two independent variables, they must not be correlated. And this is why this is very, very important. This particular matrix we did, they must not be correlated. Once they're correlated, you need to drop one of them. For example, now extraversion and openness. I think extraversion and openness. So this is openness and this is extraversion 0.267. So we can proceed with this. They don't have a strong correlation. So we can actually proceed with them in the same analysis. But once you have something like 0.9, 0.8 between openness and extraversion, then you need to drop one of them because we already have what we call a multicollinearity problem. Then we have autocorrelation tests. We have tests for autocorrelation. That means observations are not dependent on previous observations. Then we also have what we call Cook's distance. This is test for outliers. And we also have Manolobis distance. So a lot of these are actually important in deciding whether you are proceeding with a regression analysis or you need to find another kind of regression that will suit your task. So we have R square, we have adjusted R square. They are already part of the results. This is it. I think it's already checked where I did. So this is it. So this is the amount of the variability that is explained by independent variables. So that's what we refer to as the R square. So usually we usually want a very high value, but it also ranges from 0 to 1. So because it's like expressed in percentage, so it ranges from 0 to 1. So usually we want, if possible, we usually use the adjusted R square. There are two different things. You can see the R square is 0.254, adjusted R square is 0.248. So we prefer to use the adjusted R square because the R square, the problem with the R square is that the more you increase variables, the more you add independent variables, the more the value increases. Unlike the adjusted R square that is actually increases based on significance, because you can see not all of these values are significant. These two are not significant. Sorry, this one is not significant. This one is significant. This one is the one that is not significant, 0.054. So you can see when we add more variables that are not significant, this one will increase, will be increasing. Why this one will only increase based on values that are actually contributing something to your regression model. So that's what makes them different. So mostly, this is actually the most preferred when one is conducting research, you use the adjusted R square. Now also have some of these values, AIC, BIC, they usually is for comparing models. So you also have your model coefficients. We also have some settings here, estimated marginal means. So also have save, you want to save some of your predicted values. So a lot of these settings, you can just on your own try to explore them after downloading it and maybe just run it on some data sets that you already have. So is this part of regression clear?
Yes.
Okay. Thank you. Okay. Are we there?
Yes.
So the next I'm going to be going for is testing categorical data using chi-square. So I'm going to be testing categorical data using chi-square. So chi-square is actually a type of test that we use when we want to try and see the relationship between two categorical variables. So you have two categorical variables, you want to see the relationship, you use the chi-square analysis. So I think if you go, for you to go to chi-square, you just go to frequencies, and you can see it's an independent sample test of association. So our dose and supplements are two categorical variables that we have. So if I click supplement and take it to rows, click dose and take it to columns, you can see I'm having this particular contingency table. So you can see my contingency table, I have three variables, 500, 1000, 2000, OJ, VC. So this is my p-value. I'm having a p-value of 1. So p-value of 1 is actually higher than what my level of significance, which means that there is no significant association between the two categories. So this is how you conduct a p-test. So you have this statistics option where you can add various options. We have odds ratio, log odds ratio, relative risks. You can add all of these are calculations that one can actually add. Continued correction. You have Fisher's exact test. So for those that conduct Fisher's exact test, where you use this whereby you have some of your counts to be less than 5, you can just set this for your Fisher's exact test. Then we also have other options or settings that you have here. So all of this just depends on what you are trying to, the methodology you are trying to use for your data. So you can be able to access some of these particular options. You also have post-hoc tests that you have. You also have plots. I can plot a bar plot now. So this is a bar plot of various supplements with their respective dosage. So this is the dosage of 500, this is the dosage of 1000, and this is the dosage of 2000 that we have. So the chi-square is just straightforward. Some of these settings you might not even need it, but depending on what you need, you can just try to look for any of them in this place. In the case whereby you see a particular settings that you need or you don't have, then in that it's possible that maybe your analysis is an advanced use case and you might need to use something much more advanced to analyze that particular data that you have at hand. So we have, one more thing before I go to exporting. We have this particular place here we call compute. So This, okay, I think let me use this data is better. So this is our data that we have. Okay. Okay, so we have this particular option here called compute. We also have this option called transform. Compute and transform. So compute is where you want to compute a new variable. I think I should have. Okay, we are using this. So let's use this. So compute is where you want to compute a new variable. So we have neuroticism and extraversion. So I want to compute the log of neuroticism. So I'm going to say neuroticism log. Then I'll now come to this place to type the formula I'll use. So if you click on this drop down, you have a lot of options here. So this is log in this place. Once you click on log, they are going to see the what? The logarithm is going to tell you what you are going to put in this place. So I just put only a number, which is what? Neuroticism. So I see the log of what? Neuroticism. So I'm just going to say log 10. Then neuroticism. So you can see I've already created a new variable in this place, compute variable. I can also create another variable now again. I can decide to say compute also. Another one. I can now say this one is neuroticism less than, let me say 1. Less than 1, or let me say less than 2. So we have a function here called if. There are various functions here. You can just check them. If you have this function in Excel, you should find this one very easy. You can see logical if. First of all, you give your expression. So if neuroticism is less than 2, then what is the value? Else, what is the value? So I will now say what? I'll put my if function in brackets, and I'll say neuroticism less than 2. Then the first thing is that if it is less than 2, what should we give it? I'll say give it a value of true. Else, give it a value of what? False. So, okay, so let me check it. Okay, let me just give it something like this. Then, so you can see it. So if you are typing a string, ensure you just put this particular apostrophe. So you can see I've already created a categorical data. You can use this to create categorical data based on ages. You can use something like this to create it. So this is just similar to also the compute variable that you have in SPSS. So you just used to use this particular field here, compute. They also have transform. So this transform are almost similar. The only thing that transform are just transforming a variable. They are not combining it to another variable maybe, or adding it to another variable. Because in the compute, you can add two, like scoring. When you collect a questionnaire, you ask some questions, you want to score. You can actually score them together using some of those functions. We have what we call sum function, we have add function. So you can sum together using compute. But in terms of transform, you're really transforming a particular single variable. So you can define to just say log of neuroticism. I think I already, okay, let me say log of extraversion. Log of extraversion. So I'll say using transform, I'll create a new transform now. So this is where I'm going. This $ source means what? That what is referring to that particular variable you are currently on, which is what? Extraversion. That's what that particular $ source means. So I think I might even selected the wrong. I'm supposed to select this. This is what I'm supposed to select. Okay. So if you want to delete, just delete this transform here. I can say new transform. Log 10. Then enter. So you can see this is what? This is the new one I've already created. You can say log of extraversion. So transform, these are transform variable. log of these are transform variable, log of what? Extra version. So this is how you can use the transform and the compute weight, which most of the times you might be needing them. Maybe you want to categorize or you want to transform your variable. You might be actually be needing some of what? This. So based to now, back now to reporting. So we already have your analysis now. So this is our analysis. Now, how do we now export it? You already have it now. So you have various approaches. If it's just by table, you just click on your table. Right click and you click on copy. If you are using latex, you can copy the latex table and paste it in your latex file. If you just need the table, the raw table, you just copy it and you paste it in your Word file. You can also export here. Export to what? PDF. That is this particular table. This particular table, you can decide to export it to what? To what? PDF. And if it's the whole analysis that you want to export, as you can see, or everything, you can just decide to go here, export, and say tooth growth, export. So I don't know where it saved it. Let me check. Maybe it's in my downloads. I don't think so. Let me see where it saved it. Okay, I think it's in my documents. So this is it. So this is our analysis that we have done. So this is the exported. This is all what I already export from the analysis. So this is just how you can export your analysis to PDF after I've already conducted it in what? After I've already conducted it in Jamovi. So I don't know, is it clear? Are we there? Hello?
Yes, we're here.
Okay. So if you want to save your Jamovi file, you just save it. Save as. This Jamovi's OMV. You know that of SPSS is SAV. So this for Jamovi OMV. You save it as OMV file. So that I can just save your file. And you can just sort. You can just use it or just save it to your PC. So just like you have your SAV in SPSS. So we have some free modules. I told you that I already have modules in the Jamovi that you can use. So power analysis, you can just Bayesian methods, advanced mediation models. These ones for those that are in psychology and psychometrics. So we have a lot of them. And for those that are familiar with R, you can actually create a module in R and make it available for those in the Jamovi community. It's very easy. So a lot of these were just authored by individuals. You can see their names here. These are their names. So it was just authored by various individuals, which you can also do that on your own. And one of the importance is that you can also serve as a paper. Yes, so for those who are into research, you can just create an R package or create a package for Jamovi, write a paper on it, and make it available for those that actually need a particular analysis in Jamovi. That's what makes it very powerful. It's extendable. Extend it to a lot of things. So you just want to make the analysis easy for those that are not comfortable using programming languages like R, or maybe using coding scripting languages like Stata. So those are not comfortable with that. Then Jamovi is just like more on an approach that makes it easy for them to be able to conduct such analysis. So also, what are some more common pitfalls to avoid when you're using Jamovi? So you usually use the correct measure type. So when you have continuous, make sure it's recorded as continuous. It can affect your analysis. If you record it as categorical, you might have issues. If you also have skipping assumption checks, a lot of people have noticed this a lot, especially those that are not that heavy statistical background. They just think every analysis works like that. For example, now counting the number of individuals in the hospital, a lay person will think, yes, use regression analysis, whereby we have the proper use linear regression, whereby we have the proper regression analysis you are supposed to use, which is actually a Poisson regression, a negative binomial regression. Those all these are very important. Checking for assumptions. So they can actually having the wrong methodology can violate one's work, or you just be reporting false information. Also, ignoring missing data. So I think I'll cover this later in future webinars, God's willing, how you can impute missing data or take care of missing data. And also forgetting to save as .omv. So if you save as a CSV, is a problem. You might lose your Jamovi analysis or your reports or your whole session. It's always good to save as a Jamovi file, just like you save it in SAV in Jamovi. So it's also important you also save it like that in you save your file as OMV. So if you want to learn more, jamovi.org is there. They have documentation. I think it's very easy to learn some of those functions I talk about, other advanced cases, and also the user guide is there. I think the user guide even explains the right analysis for you to use, the proper analysis, proper way. It's very extended. This session is just a tip of the iceberg. You can actually go to some of these sources to learn more. You have the community forum. A lot of people ask questions. I have this analysis I want to do. How do I do it? You have the Jamovi cloud. If you want to run on your browser, you don't want to run on your system, you can use the Jamovi cloud. So I think that's the end of our session today. So I don't know if anyone has questions. Let me check the chat. Okay, so iSense Poly is asking how can I get this app installed in my PC? So maybe you came late. So I'm just going to be sharing it. This is the link. iSense Poly is still available on the session. Are you still there? Okay. Okay, I'll do it this way. I will send a follow-up with the recording and also a follow-up with the link to download it, and also some of those resources I talked about. So I'm going to send a follow-up for all of this. I think that will really help a lot. So please, do you have any questions again from the participants? Hello, are we there?
I think the
Okay. Okay, someone talking. Okay, someone talking, please.
Yeah, hello. Scenario one.
Yeah.
Yeah, thank you for the presentation.
You're welcome.
It's a very educative one. My question is, I was asking whether, I don't know whether it has been already answered because I was having network challenges.
Okay.
I was asking if the slide can be shared. I'm just asking. Although
Yeah,
I
everything
went
will
through.
be shared.
Okay.
Everything will be shared. No worry. I'll send them
Thank
email.
you for the
Everything will be
knowledge.
shared. Yeah, welcome. Please. Thank you. Yes. Okay. Okay, I think we'll call it a day. Yes, it has. It has. It has a functionality for ordinal logistic regression. So let me just give you a brief on it. This is it. Ordinal logistic regression. Can you see it here? Ordinal outcomes. I hope you can see the person that's asking the question. This is Mr. Olayinka. This is it. Ordinal logistic. This is it. So this is for ordinal logistics. So if you want to connect ordinal logistics, you can use that particular option. I think, is your question answered, Mr. Olayinka? Okay, so I think we'll call it a day. Thank you very much for attending. I'll send all these resources for the webinar to you people. Thank you very much. Have a nice day.